So before jumping right into setting up an environment and before writing any code for the components or the website, I wanted to give you a bird's eye view of every single thing we'll be doing throughout this series. As you can see on the screen here, I have this very big architectural diagram of every single thing we'll be doing, and I'm sorry that things are so tiny here. The screen is small and the diagram is so big that I cannot fit it in a small screen, but I'll try my best in order to zoom I'll try my best to zoom in and out and try to explain to you every single thing that's going on in this diagram. And whenever we are building something, whenever we are starting a project, the first thing we need to do is we need to have a diagram. We need to have a plan of what the project is going to be. So having a diagram like this will be super beneficial in the future, and also it looks more professional. So whenever I'm showing something to the client and if I show a diagram, then they will be really flabbergasted. Okay, so I think having a diagram like this of the entire having a plan in a diagram, I think it's much beneficial. It's super helpful. So, and if anything changes in the future as the series progresses, as we go on with the project, if anything changes, we come back, update the diagram, so that in the end, when the code base is so huge, like in this series, the code base is going to be really huge. When in such a huge code base, having a diagram like this really helps in order to understand the entire project structure and in order to understand what the end goal is and what the overall plan is. Okay, so as you can see on the screen here, you see that these two CI/CD pipeline, these two big boxes, this is an added bonus. As a front-end developer, I do not think a lot of companies or a lot of managers expect you to know or have a lot of cloud knowledge, but I think it is always an immense help if you have some cloud knowledge, at least if you at least know the core concept behind clouds, or at least if you know how to deploy a site and keep making updates to the site in an automated fashion. Okay, so this will be an added bonus. We will, at the end of the development of the component library, we will build a CI/CD pipeline that will automate the process of deploying that component library to NPM registry. And same thing with the documentation websites. Since that documentation websites we'll be building will be a static site, so we will build an automated CI/CD pipeline in order to deploy those static websites to an Amazon S3 bucket, because Amazon S3 bucket is always great for hosting static sites. So let's get this started. There are a few core concepts we need to understand in this architectural diagram. The first concept is about the concept of Monorepo architecture, and the second thing is about microservices architecture, and the third thing I explained a little bit will be the CI/CD pipeline or the deployment process. Okay, so let me zoom in and then let's come to the left here. You see this big box. This is basically just a package.json file. This mod.js is the name of the package we'll be building, and this mod.js will also be the name of the organization because we will be using scoped packages in NPM. So you see that at mod.js, whenever in package.json, when we specify the package name starting with at, and then the package name, it means that at mod.js, that's a scoped package. So every single packages, every document, or all these documentation websites, all these packages will be under mod.js scoped package. Okay, so this is the root folder. So we will create a folder name. This will be a root folder. We'll create a folder name called mod.js. You can name it whatever you want based on the name of your organization or based on the name of the project you are working on, but in my case I will name it mod.js. So inside this mod.js folder, the root folder, there will be a root package.json file, and this is the concept behind Monorepo. So inside the mod.js root folder, we will have a file called package.json file, and inside that package.json file we will specify the package name as at mod.js/monorepo. Version will be v1.0.0. so we'll come to this versioning or semantic versioning later in the series, but the package name will be at mod.js/monorepo in package.json file, and in package.json file in this main root package.json file, we will have every single packages that we need for this project. So in this case, you can see that we have Babel, we have Babel Core, Babel PreCDNB. So these are all Babel packages. We will install Cypress. So Cypress, if you do not know what Cypress is a testing framework. It's a end-to-end testing framework, and it's also a component testing framework. So we will use Cypress in order to component test all our packages, and we will use end-to-end test in order to test the documentation website. Okay, and we will also install ESLint. We will use ESLint because when we are working in a team, the entire code base should be consistent. So ESLint, and we'll also use Prettier so that the entire code base is consistent. We will use testing library React. This is mainly for writing unit tests, and we will use install this package types React DOM. So these are all the TypeScript types. We need to install this. And we'll also use vtest. So this is again for unit testing. So Babel plugin style components, that's another package. And the entire package, the styling of the packages that we'll be building, the library that we'll be building will be based on style components. And there are a few other packages that we'll need. We'll install TypeScript, and we'll also install Webpack. All these packages will be installed in the root folder, in mod.js folder. That's a root folder. Okay, so this is what the Monorepo architecture is. And what happens when you do this is, so inside this mod.js folder, we will have package.json file, and inside that mod.js folder, we will have two other files. We'll have two other folders, sorry. We will have a folder called documentation, and we will have another folder called packages. So this packages folder is the folder that will actually contain our packages. So in this case, we will build 4 packages. So the first package will be mod.js/core. We'll build mod.js/icons. We'll build mod.js/helpers. We'll build mod.js/utils. So this, again, this mod.js at mod.js, that's a scope name. The actual package name is core, icons, helpers, and utils. So when we use scoped packages, all the packages that we will develop will be under a scope name that is mod.js. Okay, so and when talking about Monorepo architecture, so in all these 4 packages, if let me zoom in a little bit. So in this mod.js core packages, there are only these dependencies that will be in package.json file. So that will be React DOM style components. And again, this mod.js core will depend on another package, mod.js helpers. So these are some of the helper, this package will contain some of the helper functions. We will write, as you can see here, some of the helper functions are format phone number, format email, validate email, and there are tons of other functions, plain JavaScript functions we'll write. And all these JavaScript functions will be required in mod.js core in order for maybe phone field to work correctly, maybe email field to work correctly. So mod.js/core is dependent on mod.js helpers, but all the other packages, all these packages, these packages that are in the root, because we will be using Monorepo architecture, we do not need to install all these packages here again in mod.js/core. Okay, and same thing with icons. This icons package will only have this dependency, React DOM style components, and mod.js/utils. But again, this icons component will automatically inherit all the packages installed in the main monorepo. Okay, so that is the benefit of having a monorepo. And again, another benefit of having a monorepo is because these 4 packages are interrelated or interdependent with one another, right? So what will happen is when these packages are dependent on each other, and then since we'll be building this component library in a local environment, there we will need to link the packages to one another when we are in development. And when we are using Monorepo architecture, that linking, that is also called a symbolic link, which we will talk about when we actually start installing the packages in the next video and start writing code. But that symbolic link will be automatically created whenever we use a monorepo architecture. And also the other advantage of using a monorepo is every single thing, all the code base of mod.js is under one folder and everything is well managed. So that's another benefit of having a monorepo architecture. Okay, so inside this mod.js folder we'll have packages folder, right? And inside that packages folder there will be 4 other folders for each of the packages, and inside each of these folders we will have all the components. So for Mod.js core, we will have button, password field, code editor, source field, etc. And there are over 100 other UI components under Mod.js core. And in a Mod.js icons, we have React icon, email icon, settings icon, GitHub icon, and there are over 200 other icons component that we will be building. And if you do not know what I'm talking about, go and watch the part 1 of this series, where I actually showed you the demonstration, where I have gone through the entire demo of what the end product will be like. I have showed the components we'll be developing. I have showed the documentation website we'll be developing. So go and watch that part 1 of the video to get a better insight into into everything that we'll be doing in this series. Okay, so there are 4 packages on Mod.js helpers. As I said, there will be some of these plain JavaScript functions. And for Mod.js utils, this can also be called a base package, or Mod.js/base, because this will contain some of the basic functionality, some of the foundational functionality of the component library. So in this case, it will supply a theme provider so that the end user using our packages can apply theme or light theme or dark theme to their app. We'll also write some hooks, use media query hook. So this is to see what the screen size is. We will write a custom use media query hook completely from scratch. And also there will be with layout higher order components. So there is a lot of React concepts that we will be digging in throughout this series. So this series will give you a lot of knowledge, a lot of understanding about React, TypeScript, and about front-end development in general. Okay, so that's for the packages folder. Before jumping to the right, let's come down here. So inside this Mod.js folder, we have packages folder, right? So that is explained. And inside that Mod.js folder, we will also have another folder called a documentation folder. So this is the folder that will contain our documentation website, okay? And so we talked about the concept about Monorepo. The second concept we will talk about here is a concept of microservice architecture. And this might not feel like complete microservice architecture, but in basic terms, in basic understanding, microservice architecture is nothing but we take a big app and then we break that app into smaller tiny pieces. Okay, so that's basically what microservice architecture is. So what's going on here is inside this documentation folder, we have 1, 2, 3, 4, 5. We have 5 apps, and these are all different apps, and these are all Next.js apps. Okay, so we are taking a big chunk and then a big app, and then we are breaking that app into smaller pieces. So in this case, we are taking a big documentation website and we are breaking that website into 5 individual website, and all these 5 websites. So one of them will be Mod.js marketing site. So this will be a Next.js app for the marketing website for Mod.js. We'll have a separate Next.js app for a core site, for icon site, separate Next.js app, and same for the Mod.js util site and Mod.js helper site. So this is what a microservice architecture is in simple terms. So what is the benefit of following a microservice architecture? What is the benefit of breaking all these apps into breaking a single documentation website into 5 different websites? And the most visible advantage of this is, as you can see, when we break the website into the main documentation website into 5 different sites, the code base gets a little bit smaller and it's easier to find, it's easier to manage. Okay, that's one clearly visible advantage. The second advantage to microservice architecture is when it comes to deployment, when working with team. Okay, so when it comes to deployment, let's say that in Mod.js core site, let's say that in Mod.js marketing site, I have a simple spelling error somewhere in the website, and in order to fix that simple spelling error, I fix the error, and after I fix the error, I will need to deploy the marketing site, the new version of marketing site, to, in this case, Amazon S3, right, to production. So what happens is when I'm following a microservice architecture, when we follow a microservice architecture, when we deploy this Mod.js marketing site with the corrected spelling, we are only deploying this Mod.js marketing site. And every other sites, all these 4 sites, will be left alone. Because when we there's only an error in the marketing site, we only deploy marketing site, and we leave everything else unaffected. Okay, so that's the advantage of another advantage of using microservice architecture. And also, so there will be various teams in a real world scenario. There will be a team of maybe 15, 20, 10, 5, whatever the number is. And each of those team members or each of the developer will be working on certain functionality on the website or certain aspect of the application. Okay, so in this case, maybe there will be 5, since we have 5 different websites, maybe there will be 5 different developers working on each of the sites. So when it comes to deployment, when one developer deploys changes to Mozzia's marketing site, none of the other developers are affected when using microservice architecture. If we were not to use microservice architecture, then we would have every single website code base inside the documentation folder, and when it comes to deployment, we will have to deploy the entire documentation site, even for a small spelling error. And when that happens, every other team members, every other website is affected. And if something breaks, then we'll have to roll back. And that can get really, really tedious. So that is another advantage of using microservice architecture. And the next advantage of using microservice architecture is when it comes to trying out new technologies, because technology is always evolving. You do not want to get stuck at a single technology. But what happens when you use microservice architecture is, so inside this documentation folder, we have 5 different websites that are completely isolated from each other. So with microservice architecture, what we can do is, so right now all these 5 websites are Next.js app, right? So instead of maybe I do not want to use Next.js app in all 5 sites. Maybe I want the marketing Mozzia's marketing site just to be a plain React app, or created by using create React app. So we can do that when we are following microservice architecture. So inside the documentation folder, we have 5 different sites. Maybe 4 sites are Next.js app, and maybe I want to try out a new technology. In this case, maybe let's say that I want to try out just by using I want to try using create React app. I can do that. Just the Mozzia's marketing site can be built using create React app, and the remaining websites can be Next.js. And if I wanted to try out maybe another technology, I can get rid of the Next.js app and maybe configure another technology for that particular site. Maybe Mozzia's icon site, I do not want Next.js app, I want something else. We can completely do that using microservice architecture. Okay, so that's the benefit of microservice architecture. We talked about Monorepo, we talked about microservice architecture. And again, when it comes to using Monorepo, all these packages here in the root Mozzia's folder. So maybe let's say that all these Next.js app, the documentation website, we want to use ESLint or Prettier or maybe TypeScript in this in all these websites, or maybe one of these websites. We do not need to install the packages, the ESLint or TypeScript here in individual app. We can just install it in the root folder in the Monorepo, and all these sites will automatically inherit the packages installed in the Monorepo or in the root folder. Okay, so that's about Monorepo and microservice architecture that we'll be following throughout this series. So the next thing is, let's talk about the deployment pipeline, the deployment process, the automated deployment process we will be setting up as we get done with the component library and as we get done with the documentation website. So in order to understand this better, let's say that right now we are doing this as a solo developer. We are doing everything else on our own. But let's say that we have a team that is working on the component library, maybe a team of 4 people, and each of these developers are working on particular library. So this guy here is working on Mozzia/core. This guy is working on the icons package. This guy is working on the helpers, and this one is working on the utils package. For deployment process, so let's say that for the core side, this developer is working on, what will happen is this developer will commit changes, will write the code in his or her local computer, and when he is satisfied with the code he has written, with what he has built, he will push the changes to GitHub. And when this developer does that in GitHub, he will push the changes to a GitHub feature branch. He will first create a feature branch in GitHub, and then he will push its changes to feature branch. Okay, so that's the symbol for feature branch, and that's GitHub. For the component library, we will be using GitHub as a code repository. So once this developer pushes changes to a feature branch in GitHub, what we can do is, and this is all for continuous integration, right? If you do not know what CI/CD is, okay, but let me first explain that to you before jumping into anything else. CI/CD stands for continuous integration. CI, okay, CD stands for continuous delivery, and it also stands for continuous deployment. So when somebody says CI/CD, you gotta ask them if they are talking about deployment or delivery. And in the first scenario here, we are talking about CI, we are talking about continuous integration, okay? And continuous integration consists of code phase. Okay, code phase is everything to the left here. That's a code phase, and this part, continuous integration part, consists of build, integrate, and test. So we'll be doing this build, integrate, and test in continuous integration part. Okay, so let's come back to how the developer does it here. So the developer pushes changes to a feature branch in GitHub, and once that change is committed, we can trigger a webhook. That webhook will tell a Circle CI to create a build server. That build server will run npm run build, probably in a buildspec.yaml file. Okay, and this npm run build command will also run all the tests we'll be writing. So Cypress component test, unit test, using vtest, end-to-end test. So this npm run build will run the build, and it will also run the test. And once the test is run, it will give us a test coverage, and we will do this. We will get the test coverage for all the code we write. So in this case, if the test coverage is, well, let's say maybe 80%, 90%, 99%, everything is good, we are satisfied. If did any test fail, if it did not fail, we can again trigger another webhook, and that webhook will tell GitHub to create a pull request. And once that pull request is created, we will go to the top here. Okay, so once that pull request is created, we will, so all these, if there are multiple developers working, so in this case it's only me, it's only you, but if there are multiple developers, in this case it's not, I, or all these developers, or I will vote whether to approve that pull request or not. There should not be this developer here. This developer should be on top. But anyways, I will vote whether to approve or disapprove that pull request. And if everything looks good, if this developer has done everything correctly, if everything is working fine, then I will approve that pull request, or all these developers will approve that pull request. And once the pull request is approved, this feature branch, this main feature branch of this developer, will be merged with the main branch, also called, it used to be called a master branch. A lot of people don't use the word master anymore, but they use the word feature, or sorry, main. So this feature branch will be merged into the main branch. And what will happen after merging this feature branch into the main branch is we can again trigger a webhook that will tell Circle CI to create a build server. That build server will run npm run pre-publish. So this is the custom command we will be running. And right now we are in deploy phase. The middle section here, I forgot to explain, this was the continuous delivery phase, or also called the release phase. Okay, so this is basically releasing the developers' changes to the main branch, so that's why it's called the release phase. And for the deploy phase, we will run this npm run pre-publish. So this is the second last step before we publish the changes or the component library to npm registry. So once that npm run pre-publish is run by the build server, we will again get the test coverage. If the test coverage is 99% and none of the tests fail, then we will run npm run publish, and that will automatically publish the component library, all the packages, to the npm registry. Okay, so that's the entire deployment pipeline that we will be doing as an added bonus. And again, as a front-end developer, I don't think a lot of managers or the companies expect you to know in greater detail about DevOps, but I think it's always greatly it's greatly beneficial if you know at least the core concept about how everything works. Another thing is, so what happens? So let's say that we run npm run pre-publish and test coverage. It will still give us a test coverage, but what happens if any test fail? Okay, so let's say that in the deploy process, some of the test fails. Okay, so what are we going to do at that time? So what we can do is, because all these are pipes, right? It's a pipeline. All these are pipes. So if you blow into a pipe, into the hole on the one side of the pipe, then there can be some dust and debris that are lying around in the pipe, which can clog the pipeline. So if we just maybe blow the pipe with the mouth or use a vacuum to suck all this dust and debris out, it will pass the test. No, I'm just kidding. That doesn't happen. When the test failed, we will just roll back. But yeah, that is the entire CI/CD pipeline for the component library. Okay, and this loop will continue every single time. So let's say that we will first publish this to npm registry, the package to npm registry, and let's say that later on, of maybe a few days later, we realize that we made some error, or we do not want the behavior, the functionality isn't working well. Then we will correct those, and again this developer, or I or we, will again go through this loop again in order to deploy the changes. Okay, so that's for the CI/CD pipeline, the deployment pipeline for the packages. So let's talk about the deployment pipeline for the documentation websites also. Okay, and this is exactly the same as the CI/CD pipeline for the component library. Okay, for this CI/CD pipeline, the only thing that is different is that we are using all things AWS. Okay, so we are using code commit, Lambda, code build, S3 bucket, since the documentation website will be a static website. S3 bucket are really great to host static sites, so we'll be deploying this documentation website to Amazon S3 bucket. Okay, so let me explain this CI/CD pipeline too, and too quickly. So again, here, when this developer, maybe this developer or I or you, will be working on Mod.js marketing site. So I want to deploy this marketing site to Amazon S3 bucket. So the entire pipeline for this would look like, so in continuous integration phase, we have code, build, integrate, test. The code phase is already done in this continuous integration phase. Now what we'll do is we will do a build, integrate, and test. So this developer will create a new branch called a feature branch in AWS Code Commit. If you do not know what Code Commit is a code repository exactly like GitHub. GitHub, I believe, is owned by Microsoft. Code Commit is owned by AWS or Amazon. Okay, so this developer will create a feature branch, push changes to the feature branch in AWS Code Commit, and once that push is done, once the change or the code is committed, we can trigger a Lambda function. That Lambda function will tell AWS code build. So before this was Circle CI, but now since we are using all things AWS code build will create a build server. That in that build server we will run npm run build, and once that is done, it will give us the test coverage 99%. None of the tests fail. If none of the tests fail, then we will deploy that artifact to an Amazon S3 bucket, and this artifact will basically contain the test information, okay, the build information. We will store this artifact in the S3 bucket. Artifact is just a fancy name for a zip folder or a build or a dist folder. If you are familiar with Webpack or Next.js, the output will be in a build or the dist folder. So that's basically what the S3 bucket contains, and that's what's called an artifact. So that's for the continuous integration. So we are now in the release phase. Everything is working fine, right? In the S3 bucket, the artifact is in the S3 bucket. It means that the continuous integration was successful. So now it's time to come to continuous delivery, which is also called a release phase. So what we can do is, as soon as that artifact is stored in an S3 bucket, we can trigger a Lambda function. That Lambda function will tell AWS code commit to create a pull request, and once this pull request is created, all these developers, I or you, will vote whether to approve or disapprove that pull request. If everything looks good, everything is working fine, we will approve the pull request, and then this feature branch will be merged into the main or the master branch. Okay, so that's for the continuous delivery. The release is done, and now we are in the continuous deployment phase. And you might have noticed that there are two phases in the deployment process. There's a staging phase and deployment phase. Okay, and you can get really creative with CI/CD pipeline. It's not a hard set rule that you have to follow exactly this process. You can get really creative with it. Okay, and you can add a staging stage, or maybe you know what, in this approve pull request, you can maybe add another stage, like after release, before release stage, you can maybe add another stage called an approval stage, so that when you are working in a team, the main manager, your manager, have to approve that pull request in that particular stage. Okay, so you can get really creative with CI/CD pipeline, but this is I think this pipeline works out pretty well, so we will just be following this throughout the series. Okay, at the end of the series, I mean. So for continuous deployment, as soon as that feature branch is merged into the main branch, continuous delivery is complete, and in continuous deployment, we will trigger a Lambda function. Once the feature branch is merged into the main branch, we'll trigger a Lambda function. That Lambda function will again tell code build to create a build server. That build server will again run npm run build, and it will give us a test coverage of 99%. Did any test fail? If none of the tests fail, then we will proceed. If any test fails, then, as I made a really bad joke earlier, we are not going to do that. We are just going to roll back and fix those errors, and then again continue all this CI/CD process again. But if none of the tests fail, we will tell AWS Code Deploy to deploy the main website. Okay, in this case Mod.js marketing site. AWS Code Build or Code Deploy will deploy the website to an S3 bucket, and this S3 bucket this will be a staging bucket in a real world application. It is always better to first deploy the changes or deploy the code to, or deploy the app to a staging bucket. So this staging bucket is not a production bucket or a production server. This is a staging server where all these developers will come together and they will do a manual quality assurance. Maybe they will check whether maybe that link that was broken before, now that link has been fixed. So they will use the staging bucket in order to check whether that link is actually working or not. Okay, and this staging bucket is only for developers or the quality assurance team. End users, nobody outside the team can see that staging bucket, that staging server. Okay, and so once the quality assurance is done, the quality assurance team will say, okay, everything looks good, and then AWS Code Deploy will deploy the final application to a production bucket. This is also called a production server, and this production bucket is where the live static website is visible to us, to the developers, to everybody out in the world. So that's the entire CI/CD pipeline, and again, these pipelines are an added bonus to this series that we'll be developing. And throughout this series, I might have gone or spoken too fast. I usually speak really fast, that I'm trying to improve. But when I get really excited about things that I am doing or I want to do, I get really excited and I speak really fast. Okay, but I'll try to slow down like I did in the last video. But I also want to get things done pretty quickly instead of being too slow, because you can always decrease the playback speed if I'm too fast or increase the playback speed if I'm too slow. But let me know what you think in the comments down below. And one thing I wanted to mention is this diagram can be really overwhelming. This series can feel like it's really overwhelming, especially if you are a beginner. Please do not worry about whether you will understand the concepts or not, because I was a beginner too once. I was new to all these technologies. I was naive to all these technologies, and I can feel that. So what I'm going to do is, even if you do not know a single thing about React, JavaScript, or even HTML, CSS that we'll be writing, or anything that we'll be doing, do not worry about it, because I will retrospectively recall when I was a beginner and what are the problems I had when I tried to understand certain technologies or write certain functions. Okay, so I will explain that in complete detail, so do not worry about it. I think even not just for beginners, I think even if you know front-end development, I think this series will be an immense help, because in this series we are doing more than just doing a front-end development. We are trying to be a complete front-end developer that also has cloud knowledge, that knows how to deploy a website, that knows how to make changes to a website day and day again. Every single day there needs to be changed. So we're trying to be that kind of front-end web developer in this series. Okay, so And this is not the final architectural diagram. As this series progresses, there might be some changes that we'll need to make, so we will come back here and then we will make this architectural diagram. And just so that you have that diagram too, I strongly recommend that you go to, this is a really nice website in order to create an engineering diagram, app.eraser.io. Make the exact diagram once. I highly recommend you to do that. Make this exact thing. I will zoom in and out so that you can pause the video and make the exact diagram that I have, and this will give you a very clear understanding of everything we'll be doing in this series. Okay, so let me zoom in that too. So take a pause the video, create that diagram. Okay, so over here too, pause the video, create the diagram. Okay, same here. Yeah, let me scroll down so that you can pause this and then create the diagram. So yeah, that is the complete diagram. So that was it for we did the demo in the first video. I did the demo in the first video. In this video, we talked about the architecture, Monorepo, Microservices Architecture, and everything that we'll be doing in the series. Now in the next video is where we'll actually start setting environment up, where we'll actually start writing code. Okay, so I think you found this video useful. At least you learned something. Would you mind hitting that subscribe button for me, or maybe even a like button if you found this video useful? But anyways, I will see you in the next one.